Okay, everyone, thank you very much for attending the MSB conference today, the Market Strategy Board. Today, we will discuss the Safety in the Future white paper, which was published in 2020. And we have a list of speakers here from the project and also from industry and from regulations and conformity assessment and project team members. So I expect that we'll have a lively discussion. The format of the conference today is to have these keynote presentations and other presentations, and we will allow for a 5-minute question and answer period at the end of each presentation. I ask you to use the chat box, and I will monitor that as we go through the presentation session. We are scheduled for 2 hours, so unfortunately we may not be able to get to all of the questions that you submit, but I will have a record of them, and if anything comes up that we would like to share with the speakers, I will definitely do that. So at this point, I would like to turn it over to the IEC President, Dr. Yinbiao Xu, who will provide some opening remarks for us. Thank you very much. Dr. Xu, please.
Thank you, Peter. Good morning, good afternoon, and good evening. It's my great pleasure to join you for the conference on the MSB. The theme of this year's MSB conference is Safety in the Future, based on the title of the IEC white paper published in October 2020. Every year through the MSB, the IEC publishes one or more white papers or technology reports that ensure that IEC work supports global challenges in electrical technology. The MSB has produced 16 white papers since 2010 on several strategic topics such as artificial intelligence, smart cities, global energy interconnection, and electrical energy storage. These are very important topics for IEC future standardization work. As many of you know, the IEC has established a task force to develop a new IEC strategic plan, and the MSB has also set up a mirror working group to support the activity. Thanks to its contribution, the task force has come up with a proposal for the new IEC strategy. That is, IEC will deliver solutions for enabling a digital and more electric society and provide trusted collaborative services to foster a sustainable world. The new strategy has set visions and directions for the future IEC development. This means we need to set priorities to our standardization activities for emerging topics, including digital transformation and the digital economy, carbon neutrality, and energy transition, waste management, and the circular economy as highlighted in the strategic plan. I would like to thank you in advance for your attention over the next 2 hours to the 7 speakers we have aligned for today's theme. Safety in the future. For now, I wish you a successful meeting. Thank you very much.
Thank you very much, Dr. Xu. Thank you for your opening remarks. They're much appreciated. Next, I'd like to introduce Dr. Kazuhiko Tsumi, the IEC Vice President and also Market Strategy Board Convener. Dr. T.
Thank you, Peter. Good morning, good afternoon, good evening, and welcome to the MSB conference. To begin, I would like to express my appreciation to everyone for taking the time to attend today's session. Thank you for coming. I'm Kazuhiko Tsumi, IEC Vice President and MSB Convener. Currently, I am also a corporate advisor at Mitsubishi Electric Corporation in Japan, having previously served as the company's CTO looking after technology R&D. I'd now like to open a bit with an explanation of the MSB, the Market Strategy Board. The MSB is tasked with identifying the principal technological trend and market needs in the IEC's fields of activity. The MSB also sets strategies to maximize input from primary markets and recommend prioritize for the technical and conformity assessment work of the IEC. The slogan of the MSB is bringing the world to the IEC. Membership of the MSB is comprised of top-level technology officers appointed from industry who works on the MSB's primary output white paper. You will shortly be able to receive the 2021 white paper titled Quantum Information Technologies, becoming available within this month, actually. An MSB conference was first held during the Busan General Meeting in 2018. At the MSB conference in Shanghai in 2019, we had many participants from the top management of NC's members of CB, SMB, and CAB members of the IC. The Shanghai conference was well attended and a lively one. However, due to the pandemic last year, the size of the IEC meeting was minimized, and we had to forego the MSB conference. A great pity, but we kept on working nonetheless. This year, the MSB is still holding its event in virtual format due to the lingering effect of the pandemic. This year, in some shape or form, the MSB was determined to hold the MSB conference no matter what. So, in consultation with MSB Secretary Peter Rankot, the MSB decided to hold this year's conference as a full virtual event. I would like to thank Peter and other staff at the central office for arranging the program, arranging for speakers to be introduced later, and for running the smooth registration process that enabled all of you to take part. The theme of this year's MSB conference is Safety in the Future, same as the title of the IEC white paper publication on October 2020. It summarizes the impact of collaborative safety not only on industry, but also on the way people live and the way government and companies think about safety. Based on the recommendations of the white paper, a task team has now been set up in the SMB's Advisory Committee on Safety, or ACOS, to develop international standards on the collaborative safety. I also understand that the CAB is also part of this task team. A big thank you to Ralph, SMB chair, and Sean, CAB chair, for making their bodies an integral part of the safety in the future. Now, I'm pleased to briefly introduce today's speakers. Peter will give you more detail later. Dr. Reinert, Director of the Institute for Occupational Safety and Health in Germany, will give us his assessment of the white paper from reader's point of view, and who will also touch on the social changes that the white paper foresees. Today's other 5 speakers were part of the white paper project team itself. Professor Cohen van Kurik was the driving force behind the project. He will talk about the significance and overview of the project and paper. Dr. Fujita and Dr. Kajiya will speak about how standardization of collaborative safety and the development of CA systems based on such standards will contribute to the future of society. Mrs. Julian Hamilton will speak about the importance of seeing safety and risk reduction activities, not as a cost, but as an investment in the future value of companies. And finally, Philip Joel, current ACOS chairman, will speak about the future direction of collaborative safety and related standards. I can assure you that this group of speakers have some very interesting things to say. So, Peter, would you please facilitate the rest of the conference?
Thank you, Dr. Desumi. Appreciate your opening remarks. Yes, at first keynote speaker today, I'd like to introduce Dr. Dietmar Reinert, Director of Institute of Occupational Safety and Health of the German Social Accident Insurance. Dr. Reinert, the floor is yours.
Thank you very much. So first, let me try to share my screen with you. So can you see it?
Yes. And
so,
yep, in presentation mode. Okay.
Thank you very much to invite me here for this meeting to give a keynote. That's a really great honor for me. When I started in 1988 my professional career, computers were not allowed to work in safety applications with machinery. So we can say at that time we worked with safety 0.0. When Dr. Fujita sent me the paper, the ISC paper, Safety in the Future, and he also sent me some of his presentations. That is one of his slide of one of his presentations. I thought this is exactly what I thought, what I lived the last 20 or 30 years for. And so I will give you some remarks on this Safety in the Future paper. So when we begin in the 90s, 80s of the last centuries, and this is also today not an easy machine to handle with a circular saw. It's really very dangerous. We still have more than 100 accidents per year in Germany where people lose hands and fingers. You have a high risk of cutting, being drawn in, workpiece kickback, thrown out pieces, workpiece parts with a high velocity. We have a protective hood, you can see it there, push sticks for small pieces, you also can see there on the table. You should never wear gloves, it's very dangerous, and you should use sharp and crack-free circular saw blades. And of course, you can see it perhaps at the picture, a local suction. But it's clear this is a safety 0.0 situation. You have the hood, but more or less your fingers are very near to the blade and you have, unfortunately, accidents with this machine. In the 1990s, we had the first discussions with machines, machining centers, and we had discussed there also it's the ISO new modes of operation, manual intervention we called it. And the point was, when you open the door there, that is a typical, normally it's a typical safety 0.1 situation. Normally you work with closed doors, but when you open them for the setting mode, for manual intervention, when you program the system, for example, you have to measure there, you have to introduce when the axes are moving. And the question was, is it possible to do it now as a kind of safety 2.0 for these manual intervention mode? So we in the standards, we defined a safe stopping process, safe standstill, safe operational stop, safely reduced speed, and safely limited absolute position. So how was it possible to do that? There's one slide missing. Here we have a redundant situation because of functional redundancy. You have a programmable logic controller, and you have a power drive and also numerical controller. That is already there. But what we did there, we used these different computers in the system for redundancy for safety. So we had the PLC and the numeric controller to have redundancy from the input signals for the doors and some other switches. And we had to monitor the velocity, we used the numeric controller and the power drive, and to stop the system, we also used the numeric controller and the power drive in redundancy. So we have a redundant system. And as you can see here, this was possible because in the 90s, we designed these new standards on functional safety. And I was for about 10 years the head of the German delegation of the working group which produced the 61508. So functional safety was one of my essential techniques we used in the 90s to make a machine more safe. So the first thing I want to remember and to tell you, attention, collaborative safety without functional safety is dangerous. In your paper, it's very clear you need both, but in some chapters, I think sometimes it's a little bit forgotten that functional safety is a precondition for collaborative safety. So when you look to these machines, we had also laser scanners, new machines, you can only, you protective devices, you can only use together with computers. But these are more complex. When you look to the manuals, for example, to the machining center, that was a numeric 840D, you have 265 pages to use this. You have a lot of parameters, you can see here on this picture, which are important for safety. It's a really complex use. It's much easier to use a safety 0.0 or safety 1.0 machine. The same for a laser scanner. You have also about 100 pages to where everything is defined. You have protective fields you have to program, and all these make things more difficult. And there's another thing which is coming up now, 2010, we had the first discussions on Industry 4.0. When you connect all these machines by the internet, you have a new danger because you can have attacks from outside. And what we saw when we went to small companies, that still the password of the manufacturer was not changed. After many years, you had in these machines where you need passwords to do the safety algorithms, safety performances, that they did not change the passwords. So what you can see here, it's not only technology which is necessary, it is also you need a good safety culture. And this is what we worked on for the last years. You see here a steel manufacturer in Germany coming from high accidents. You see there's a lost times injury based on exposure hours, 1 million exposure hours, and you see by going from an uninterested, reactive, calculating, proactive to a careful safety culture, they reduced the accidents dramatically. And 1.2 is really a very good number for a steel manufacturer. So what we see there, it's not only technology which makes things safe, and that is also in your paper, Safety in the Future, you need also a good culture. So the Vision Zero is important. We have these 7 golden rules, and from the 7 golden rules, the people developed the proactive leading indicators, which are very important to have a safe system, a safe complex system. So my next message is attention. Collaborative safety needs responsible staff, needs a good safety culture. Now coming back to the safety 2.0, the collaborating robots. It's not so far away from the machining center to the collaborating robots. You have also several axes. The movements are a little bit more difficult than in a machining center, but it's possible to use them in a safe way. That was, you have function safety. That was the first thing. What we did at the second time is we need limit values for the forces when there is a collision, and limit values on the pressures. So that was what we did also with universities here in Germany to measure these. We brought it into the ISO. Now it can be used. And we also developed a measurement system to check if these forces and pressures are acceptable. And the last step, and then I come back to my beginning, is that with the circular saw, for many years in the university, we developed possibilities. We began there with machining, videos, and see, can we detect people by a normal camera? So we use their artificial intelligence. And today, just this year, we get the first application for a circular saw by the biggest German manufacturer. He is using artificial intelligence to protect people. So how is it possible? It's only possible with trustworthy artificial intelligence. And you see there the joint TC where we are working on this topic. I only want to give one example. The degree of transparency and explainability plays a major role there. And this is my last slide. With this example we have there for this manufacturer, we have a good transparency because there's an own software architecture and implementation for the detection of hands and fingers near the circular saw, near the plate. And we have a control of the entire training process of this artificial intelligence system and the model. So we have a high degree of transparency, but we do not have a high degree of explainability. The reason is that we use there a deep neural network, and then it's not so easy to explain this in detail what is going on there. So what we use here are additional measures. We use here, for example, gradient-weighted class activation mapping, layer-wise relevance propagation, and or local interpretal model agnostic explanations. And with this, we can have a better explainability. So step by step, we can also now certify artificial intelligence for safety applications, which is also mentioned in your Safety in the Future paper. Thank you for your attention.
Thank you, Dr. Reinert. I appreciate your very comprehensive overview and reader's perspective of the white paper. I would like to open up the floor, the chat box actually, for any questions we have about, we're on a schedule, but if anyone has any questions, we can propose them to Dr. Reinert right now. So I'm watching the chat box if anybody has anything. Okay, I don't see anything coming in. 1 second. Yes, we can share the presentations. That will be, okay, there's a question from Sean Paulson, CAB chair, says, you mentioned certification for artificial intelligence for safety, but under what conditions?
At the end, these machines need a safety integrity level 3. And I know that up to now, we do not have these mapping to the integrity levels by artificial intelligence. But we use what I showed before in my slides, the transparency, the explainability, and all the others to accept here such a system. And of course, this is just in a standardization process. So we are also part of the standardization process. And this is the way how we do it. Yeah? With the knowledge we have today, we can accept these artificial intelligence system for such a product. We cannot hear you, Peter.
Thank you very much. Sorry. Are you providing this knowledge of certification to JTC 1 Subcommittee 42 and IEC 51508? I'm sorry, 61508.
Yeah, my co-workers are now working in this, starting with the joint working group, joint TC, what I told you. And of course, the next step will be to bring it also into the 61508. But this is some work to do before.
Thank you. And I have one more. What is the definition of safety 50 years ago and now? Is there a definition for safety?
You have a definition in ECOS, you know.
Very good. So
I'm not sure if that which
I understand.
Changed.
Yeah. So very good. Well, thank you, Dr. Reinert. I appreciate your knowledge and presentation here during this session. I will close out the questions, and we will move now to our next presenter, Dr. Koen van Gulik, who is a researcher, professor, and expert in digital transformation safety management systems at TNO in the Netherlands. Koen was also the project partner on the Safety in the Future white paper. For each of the IEC white papers, the IEC enters into an agreement with a third party so we can have a balanced view of the paper at the outcome. So I would like to turn over to Koen, and please present your why safety in the future is important. Thank you, Koen.
All right, thank you very much, Peter. I'm assuming my slides are visible at this point.
Yes, they are.
Yes, okay. So thank you very much for having me in this meeting. I indeed think that the Safety in the Future paper is a very significant step in the safety science and safety research arena. I'm actually quite happy that these kind of developments are actually coming from, let's say, an industry-sided IC standpoint rather than a government point, because it shows engagement. Just again, thank you again for the honor of being the lead project partner for this project. I mean, I'm personally quite involved in this kind of work in looking toward the future of safety, and mostly looking on the impact of artificial intelligence. And it's not just the risks that they bring in new machinery, but also the opportunities they bring in new solutions for guarding safety. And that's also something Professor Reinert said earlier. Thanks also to Dr. Tsutsumi for expertly leading the Safety of the Future work group. As part of IEC Vice President and being MSB convener, it certainly adds weight to the importance of this piece of work. I myself work at TNO, which is a research institute in the Netherlands, and that's actually in Rotterdam. You can see this here over my shoulder, right? So I'm in Rotterdam, just to get some assurance of where we're actually from. Okay, so and that's actually where we're looking at, research programs looking into risks and opportunities of digitalization of safety. I also work at University of Huddersfield as a visiting professor. That's on the digitalization of safety management on railways. So that's really taking information from trains and people to get to a better safety management system. I'm also involved at Delft University of Technology on their research side, developing actually new courses on this particular arena. I do think actually that the findings in this report are quite extraordinary in terms of the significance it has for industry and other parties around the world. I can't stress the significance of it as much as I guess I keep repeating myself. It's a really significant step forward in the thinking of how to deal with the safety in the future and what it actually requires for the future. And from a personal point of view, I've been researching this particular domain for 7 years, and the significant step actually really makes interest, not just in the industries and the IEC, but also outside the IEC, where academics starts working more and more on these things. Again, I'd have to just a few words of thanks to Dr. Fujita, Dr. Kajia, Dr. Hamilton, Dr. Huel, who'll be speaking here later, all expert safety researchers who have a real insight into this topic. So just moving forward, if I can find the right button. There we go. And I'll really just, I don't want to go into any technical details too much, not into the standards. I just want to stress to you how I feel about the importance of this paper. And so first of all, in terms of this looking toward the future. So safety as a concept encompasses the behavior of people in the presence of hazards, with machines mostly, modified by socioeconomic factors such as regulations and standards, best practices, individual behaviors, and interventions. And this results in outcomes that can be measured in frequency of loss or injury, and sometimes, unfortunately, in terms of death as well. And the real question then is, what's the novelty for the future? And this really has to come from the intelligence that machines are slowly imbued with. So it's the automatization that's been on the way, that's making machines more agile, skillful, competent in what they do. Machines are starting to talk to each other. Okay, so it's no longer a person working with a machine, even though the machine has algorithms too that make it smarter or seem a bit, supportive to the worker, but actually starting to talk to each other and optimizing business processes. They become responsive and change in the changing interactions. So it's not just the machine, again, just receiving some commands and doing what you ask them. They become responsive to a person's behavior, to a person's movements, etc. There really is a change in terms of how we interact with a technical environment. And then the machines just become alive with intelligence. It's not that, every machine you buy in the shop today would be, imbue with enormous intelligence and tell you what to do next. Okay, it's really not that pace, I guess, there. But intelligence does induce a new aspect to machines that we just didn't have to consider that much before, not in the way we're looking at here. And I just want to take a few pictures from the workshops that we had. So first of all, the picture on the left, that's from our report. And that's a person working in a manufacturing environment where you can see this collaborative robot arm. So it's not the arm moving on its own. It's a person interacting directly with the robot. Actually, arm is carrying the weight for the person. So even though it adds strength and agility to moving this door to wherever it needs to be, it's also under the tactile controls or the movement control of the person operating it. I mean, it's an interaction of a level that we couldn't dream of, let's say, maybe 10 years ago. On the right-hand side, just slightly more on the extreme, this is a picture that we drew on the first workshop we had in Tokyo in September 2019, if I remember correctly. Now, it just makes a little bit of a caricature of how we will interact with intelligent machines. But I mean, we will actually converse with them. We will have to, talk to each other in a way that we understand each other. So on the left-hand side, it's the tactile movement, where we can see much more interaction towards the future. I don't quite think workers will actually fall in love with the machine, but it's just to give you an idea that where all of this is going. So the measuring of the safety outcomes, that has a lot of influence on the safety management for many years, and this AI just makes it more complicated or more complex. The digitized environment allows for all kinds of opportunities of measurements, and therefore complicates the way in which you deliver safety and measure safety. Okay, so next slide, please. There we go. So just to illustrate, many of the things aren't actually that new. Okay, so here's 2 white papers from IEC that actually paved the way. Years ago, we saw from IEC being electrical engineering, oriented, we knew this stuff was on the horizon. So the edge computing white paper of 2017 showed us machines talking to each other. So in many ways, it's an obvious finding, but it's important because this machine does not just talk to the driver in the car, but to a large system surrounding it, which also makes decisions either with or without the operator. So this conversation you will have with technology on any workplace is already well captured a couple of years ago. The year after, interestingly, the white paper on AI focused on the force of AI, what it could do for industry, how it would change. And I think we're living through this massive change in industry and the way we live, which AI supports our lives. And interestingly, in that very same white paper, we have an image about human-robot interaction, okay? Directly relevant to this case we're working on. And it's, this is also about the interaction between the person and worker. The worker wants something, the machine reacts, and together they do a job. So in that sense, the trends, the important bits of the safety of the future were already in IEC. They're already being researched, they're already being studied, and already being standards being made there, as well as future visions being given. And on the safety side, it's the same thing. I mean, IEC has always been working on safety, so I got a reference here. So from 1926, if I'm correct, TC 16 on basic safety and principles of man-machine interface was in the forefront of the foremind of electrical engineering of IEC, and I guess all the electrical safety that comes with it. So in many ways, it's also just a cornerstone of how the IEC is not only thinking about safety, but also relating to how that would look in the future. And it's not just, I guess, the 1 or 2 standards that would be there. There's a whole system of standards with the horizontal standards, collating them, and the ASOC for Mr. Giles will speak about later, connecting all these things. So it's really the integrative approach to the safety thing from the IEC, from the heart of the IEC, I'd say. So in many ways, my job, and it sounds a little strange, as the coordinator, let's say, was just connecting the dots. Okay, the dots were all there. What we really did is connect them in the right way, with the right people in the right way. And a lot of findings were found. I think 3 of them stand out that really make a difference in terms of progressing to the future. The first is the IEC, can take a role as a focal point for the society value from this particular point, from safety. There's wide industry support and recognition, but it also gives us a blueprint for safety in the future, where I guess it gets more technical. I just want to say a few words about those things. So first, in the report, we'll brought that the IEC is a pillar of trust. So the IEC is uniquely well positioned to link different practices for safety in the future with the societal concerns. And in this particular image, which is one of the 3 most important images in the report, is how that fits together. There's the industry drivers, where market and innovation drive the way forward, where efficiency and economy is important, and where social responsibility is an important concept. Then there's agents of acceptance, the users who either voluntary or involuntary use the kind of technologies that are being developed. And there's dependency here with employees, and also dependency on governments and regulation. Where the IEC is more like a consensus agent, they make sure that this world actually connects well by standards, by technical consent, making sure that you can actually facilitate this collaboration. So in that sense, the IEC supports these societal values, and specifically on the safety sustainability, also with attention to the SDG. This is where I guess we go. And the safety is in the heart of it. Not only is it something that IEC was already very good at, it also connects with the technology that actually makes it happen. So it's a very important step in recognition, and I'm very happy to hear earlier that IEC is taking steps and taking this forward. But I think it's a great significant step forward in all of this. There was a wide industry engagement. Okay, I can't stress this as much. It's very important in terms to stress this. It's not just like research institute or safety research institutes like TNO or the Safety Institute from the IGSAP, but also the social insurers through ISA, Occupational Health and Safety Institutes, such as the Finnish Institute of Occupational Health and Safety, but industry was involved, okay? Mitchell Electric, they were the drawers. IDEC did an awful lot of work here, Legrand did good work here. So all these industries is showing that this is an important point, need to go forward, and something needs to change here. So that's a very important point to me. In terms of significance, it's not just some industry fad, it's not some government push, it's really something that we do together. Now let's come to the blueprint, which is, I guess, from the engineering spec, the important thing. The IC, from its nature, can work on standardization of the interfaces between intelligence agents. And this is really what this is about. So I think somewhere in the report, we said, I couldn't find it when I was just brushing through just before this meeting, but we said, the human in the working process can no longer assume that he's the smartest in the system. There's intelligent agents that work together to make a job. And in this blueprint, we call this a tripartite system. There's the 3 different let's say, main actors that we recognize. It's the human themselves, okay, being an intelligent actor, doing the work that they do. Then there's the machine they interact with directly, okay? So this could be the person we saw earlier in the factory, with an arm, could be the cutting machine or whatever. That's a direct link with the, let's say, physical link. That machine will be imbued with intelligence. Except that not all machines are intelligent, so I understand that very well, but more and more machines are imbued with this technology, especially when we're talking about robots. But there's another intelligent agent, and it's maybe invisible, okay? It's the management system sitting in the back of the factory, making sure production and orders are in line with the work that's being done. And that's often overlooked. So there's a business system in the back also communicating with the machine itself as well as the person. And this is where I guess this tripartite is everywhere, okay? There's no working place where this doesn't happen. And well, I have to be careful here. If you don't with electricity, maybe you don't. But one of the things I'm proud of specifically in this workgroup is we had, we've also considered technology being introduced in, let's say, developing countries. So let's say you have a simple electric network somewhere in Africa, and somebody gets connected to the internet with a phone. Even though we could, I guess, recognize that as a low-tech environment, that person, by access through electricity, as well as a phone, is immediately part of this system. They're immediately exposed to AI, whether it's to their benefit, yes or no. So really, this environment as we sketch it here applies pretty much everywhere. So that means work on human-centered technologies, enter AI rules, so it's multiple AIs, how do they interact? Dr. Katia does an awful good work there. The protocols that go for that. Protocols you could standardize, so that's IEC work, I guess. Then there's the messages between these agents. That's where standardization is relevant. That's where you get information about safety, about performance, et cetera. And then, as Dr. Reinert mentioned, the safety assurance, the AI safety assurance. So there's a lot of work to be done there in this environment. So in that sense, just coming to a close here. So why is it so important to me? First of all, we've connected the dots. And I really do think from the perspective we're one of the, I guess, the early ones that actually say this is a bigger system. It's no longer human machine. It's no electricity. It's intelligent agents going to the future, talking to each other and needing to do things together. I think it reasserts the IEC's vital role for safety with advanced technologies. It was always there. Okay, I think it just reasserts that position and also urges the IEC to think about this future where intelligence becomes important. And also, I guess, providing the blueprint for the future that offers foundation for practical technical standards as well as higher level for the opportunity to speak. That's more or less what I said. I feel strongly about it. It's important. Let's go do this. Thank you very much.
Thank you very much, Cohen. I appreciate your very excellent presentation and also that your support of this project as an IEC partner. I will open the floor for questions again. We have 2 or 3 minutes to do so. If you can place your questions in the chat box, I will sort through them. Just one more minute, Cohen, please. Oh, there we go. Again, some thanks for the presentation. So well received.
Thank you all very much.
Yep. Okay, one more. I have one question here. It says, isn't it at the point in time too far reaching to challenge the smartness of humans versus machines?
I don't think so. I think we need to start thinking about this quickly, right before it overtakes us. So I think it's the report is a timely moment when AI is really entering the workplace. I mean, it's been there in niches and in pockets, but it looks like it will actually come together on a much larger scale. So I think it's very timely at this point. In terms of, can we measure intelligence against a human's intelligence? I don't think that actually really matters. It's more to do with how much influence do humans still have over their life, their destiny, and I guess the safety that they control.
Very good. Well, thank you once again. I appreciate your excellent report, and you've received some great comments to that in the chat box. So thank you, Cohen.
Thank you.
Next, we have a presentation from Dr. Fujita and on collaborative safety, new holistic approach for realizing Vision Zero, which promotes safety, health, and well-being at work. Welcome, Dr. Fujita, a very active member of our project team. Please, the floor is yours. Dr. Fujita, you are muted, and
it is my great pleasure to talk about collaborative safety, new holistic approach for realizing Vision Zero, which promotes safety, health, and well-being at work. This chart shows the evolution of safety, showing that transition occurs every 20 years. In 1980, when a robot was introduced to the manufacturing site, humans are needed to be very careful to avoid being hit by a robot, and it was important to pay attention and caution. In the year 2000, various ISO and IC safety standards were created to protect people from robots. This method can ensure safety, but it is not always productive because the installation of guards are required. Nowadays, people and robots can smoothly work together with the emergence of ICT, and we decided to name it as collaborative safety. We call these three generations Safety 0.0, 1.0, and 2.0, and we are very confident that Safety 2.0 will be implemented in many applications all over the world in the very near future because it brings safety, health, and well-being to people. This collaborative safety will be applied to a wide range of environments, not only in manufacturing sites, but also in construction, agriculture, and healthcare to upgrade their OSH at work, where human, machine, and the environment will be digitally connected through ICT. Because applications are very wide, some kind of guides or international standards should be created so that everyone can benefit. And we trust collaborative safety will eventually change OSH environment drastically. Regarding standardization, we are pleased to know that IEC ACOS, Advisory Committee on Safety, already initiated such works. The chairman of ACOS, Mr. Philippe Jouel, will summarize their activities later. This slide, which Professor Dr. Dietmar Reinert used in his keynote speech, is very easy to understand collaborative safety. A robot is shown as a lion, and as you can see, 40 years ago, people need to be very careful. 20 years ago, as a lion stayed inside the fence, the safety was secured, but the high productivity was not always achieved. And from now on, we can utilize collaborative safety to enable people and the lion to communicate and work together through technical innovation. Safety 2.0 has just begun. As the SDGs of the United Nations target is 2030, and the realization of people's well-being is one of the SDGs' main themes. We believe that collaborative safety is also a journey till 2030 through application to various environments. This slide shows an example of necessity of collaborative safety because the age of mobility has just begun. Until recently, robot has been fixed in one area, but now we are in the age of mobility and the robots themselves are moving. Even in factories, autonomous mobile robot, automatic guided vehicle are running around. So we are in an era where the situation is completely different from the past. In such digitalization revolution, for example, if there is no standardization, let's say Safari Park, people have to pay attention and be careful again to what they are doing, similar to Safety 0.0. But if there is standardization, then the dangerous Safari Park will turn out to be safe and well-being Safari Park. If standardization is achieved in the field of applications shown here, the tripartite system of ICT could be applied to any kind of environment. In fact, the Societal and Technology Trend Report regarding digital healthcare was just published 4 months ago in June by the MSB, which referred to the tripartite system, and it showed the concept to realize mental and physical well-being. In order to realize this new kind of collaborative safety, not only is technology important, it is also important to take a comprehensive approach to people, management with leadership. In other words, it is important to approach all aspects holistically. This is why IC white paper was published in November 2020 to describe collaborative safety. This is recognized as a good guide that explains the future direction of technology. The IC white paper advocates realization of safety in the future, including the SDGs of the United Nations, 5.0 manufacturing, and most importantly, Vision Zero, aiming safety, health, and well-being of workers. According to ILO, International Labour Organization, which belongs to the United Nations, there are 7.7 billion people on this planet, and out of which 3.3 billion people are workers. We believe it is significant to change the working environment through new Vision Zero mindset. So we are now in a phase where we need to think about the rule making and standardization. Here is one example. Toyota Motor Corporation is promoting human-centered manufacturing to place importance on people, aiming to create the environment where people can work with machines safely with a sense of anxing and well-being. This collaboration has just begun to improve the productivity, and various trials are underway. And ultimately, Toyota is aiming for co-evolution. Co-evolution, as shown here, which will improve the well-being for all people. As an example of Toyota's grand design, I will introduce this slide. Toyota has been working on the urban city project built at the foot of Mount Fuji. New technologies such as automation, mobility, robotics, and AI are being implemented to see how people will evolve along with new technologies in a new environment. Toyota's mission is to contribute to the well-being of people, producing happiness for all. So we are excited to see what the new future of safety, health, and well-being will look like through technical innovation. We are at a turning point in terms of safety in the future. That is why we now plan to hold Vision Zero Summit Japan 2022, the important event from the perspective of international standardization of the new safety in the future, which is said to be one of the most important themes in the summit. The summit is discuss how technology, humans, and management can reach a global consensus in holistic way of thinking. We hope you will join the summit in terms of how we could promote the international standardization in safety in the future. Here are some of our previous presentations which we couldn't share with you in my 10-minute time allowance. So if you'd like further information, please kindly refer to these. Finally, I'd like to express my deepest appreciation to the ICMSB and all the project members for their diligent effort and splendid commitment in publishing the IC white paper. Thank you very much for your attention.
Thank you, Dr. Fujita, I'm sorry. I appreciate your excellent presentation. And again, we'll open up the floor to questions from the audience. For Dr. Fujita, we would just wait for a minute or so for anyone who wants to have a question. Okay, I'll give it a few more seconds. Okay, I have one question. The question is, are we really in consensus on the targets, happiness for all?
Thank you very much for asking me the question. Well, the happiness is depend on the individual, how they feel, but we are at the time to aiming all workers has the opportunity, not only just safe and health, but aiming to obtain the well-being. That is the concept of the Vision Zero. The Vision Zero concept is started in year 2017 during the World Congress for Safety and Health in Singapore. As a matter of fact, I didn't know the movement of Vision Zero, but Dr. Dietmar Reinert taught me the importance of the concept of Vision Zero. So I think the CEO of every company should consider, for the employees, aiming the happiness for all. As a matter of fact, I had an opportunity to have a presentation of Mr. Schoch, the top management of BMW. And as a BMW company's policy, BMW put the safety, health, well-being as a very important pillar. So we believe we can do that. It's our new idea. Thank you very much for your question.
Thank you, Dr. Fujita. Okay, I don't see any other questions, so we will move to our next presentation from Dr. Toshiyuki Kajiya. And the title of this presentation is Application of Tripartite System to Workplaces, Standardization Learning from Conformity Assessment Practices. Dr. Kajiya, please. Thank you.
Yes, just a moment, please. Okay, thank you, Peter. Hello, everyone. I'm Toshiyuki Kajiya, Director of the Institute of Global Safety Promotion, IGSAP, IGSAP in short. And I have been working for the conformity assessment sector of IEC communities. And first of all, I would like to express my thanks for giving me such a valuable opportunity of my presentations. My presentation is the application of tripartite safety to workplaces, especially focusing on a way forward, the standardization, learning from our conformity assessment practices, which is very much practical and not a high level talk. The first slide is what is collaborative safety? Let us review the concept of collaborative safety. This concept is briefly described in the white papers. Collaborative safety is achieved with humans, machines, and operational environment share digital information with one another, communicate, and have to collaborate. And there are several important detailed points listed on a slide, so I skip this. And we call the technical the aspects of collaborative safety as a safety 2.0. So there are three different terms of collaborative safety: tripartite safety and safety 2.0. In principle, all these three terms are the same. This slide shows a brief history of IGSAP action in parallel with the IEC moves. The original idea of collaborative safety was announced in 2015 in Japan, and IGSAP was newly established in 2016, which consists of different industry sectors, such as electronics and construction sectors, to study the new concept of safety so as to cope with smart society and the industry. In the course of IGSAP discussion, we learned that there was a need for the attestation of their new safety measures with a certain standard to demonstrate the company's attitude on safety to the interested parties. Since then, we started developing our unique standards and CA programs, and these have been reviewed and improved from time to time based on our practices. And in 2019, just 2 years ago, we had a chance to talk with Dr. Tsutsumi of MSB Convener. And finally, we agreed to propose the concept of collaborative safety into the theme of IEC White Paper 2020. It is widely said that standards and its conformity assessment is both sides of a coin, and proper standards can enable proper conformity assessment practice. This slide shows the basic principle when we started developing the standards and the CA program. For the standard developments, our main focus was put on two major aspects. One is the common applicability to the different industry sectors. And another is the performance-based standard, which can have a flexibility to adopt day-to-day evolving safety technologies. For the CA program developments, we focused on so-called system-level conformity assessment, which needs an on-site assessment on the system-level safety functionality at the workplaces. The standard and CA program development itself is not our ultimate goal, but the goal should be that they are used as an efficient tool to minimize any hazardous incidents at the workplaces sustainably. For these purposes, we believe that not only the standardization of technical aspects, but also a human aspect, such as the operators, workers, qualifications, and their overall management system should be considered when practicing our CA programs. This slide shows the so-called holistic approach in the CA program, which can be compared with a conventional product-oriented safety program. There are several challenges, but you see that COPC, Certification of Personal Competence program, would be one of the essential part of a system-level conformity assessment program in the coming years. Oh, sorry. As I mentioned earlier, it is quite essential that the standard and the conformity assessment program should be practical and should meet the industry needs properly. And we started practices of our CA program in several industry sectors. Among others, this slide shows a typical example which we made assessment last year on a tunnel construction site of Shimizu Corporation, which is one of the biggest construction company, as there were particular needs for certification to demonstrate safe working environment in the tunnel construction to the interested parties. As you can see the pictures, several machines are moving back and forth in limited spaces, and the operators sometimes need to walk around the workplaces for whatever reason. In order to prevent any potential hazardous situations in such a human-machine coexisting situations, they introduced the human-machine location management system by wireless communication devices, detection system of human access to the machine by AI cameras, and LED sequential lighting system showing the machine moving direction. By these technical measures, operators can work with a feeling free from hazard threats and psychological pressures. The assessment result was reported to the IGSAP decision committee as a normal practices for attestations, and concluded that this site complied with safety 2.0 objectives as functionality and trustworthiness of technical measures, their management and personal competence are judged satisfactory without sacrifice of the productivity, retaining a safe human-machine coexisting environment of the limited spaces. And finally, the IGSAP, the issue, the certificates. This is the interesting statistics. This slide shows the result of a survey of Shimizu Corporation, which was made to 32 employees of this tunnel construction site of Shimizu Corporation before and after the certification. 10 questionnaires relating to the workers' safety are listed in this slide. In the radar chart, the blue line shows the scores before certification, and the orange line shows the scores after certification. And you can easily see the result clearly show the introduction of this safety need 2.0 system has increased awareness on safety, and gave the positive working motivation. There are several lessons learned from our practice in terms of safety 2.0 standards and its conformity assessment, which I would like to ask you to take into consideration in your IC standardization work in the future. First one is performance-based standardization. This has a wider applicability among different industry sectors, and that has a freedom and the flexibility to employ evolving the technology in achieving objectives based on the state-of-the-art principle, and has a quite less burden in standard maintenance and revision work. And second point is for these purposes, the wide stakeholders' involvement in standards development. Because safety, health, and well-being, this is ultimate goals for all stakeholders. And by this setup of common standard objectives to satisfy stakeholders' interests. And this, as a result, value of standards compliance to be recognized by the external stakeholders outside the IEC. Our next slide shows conformity assessment of the aspects. The first one is a conduct of SLCA, system level conformity assessment, which has not been conducted up until now. This is from laboratory to on-site assessment for integrated system operations. And this coverage could be a component supplier, system integrators, or asset owners be assessed as appropriate. And the assessment methodology could be a review of technical documents and risk assessments and reductions, functionality demonstrations, and interviews on site. Another important point is the development of COPC, Certification of Personal Competence. Sustainable safety management could be enabled by the competent personnel. And this COPC program is used as an efficient tool for conducting SLCA. And by this, we can use the existing ICX COPC programs to expand it to collaborative safety. Last but not least, I would like to finish my presentation by introducing an upcoming event organized by Japan next May, which was briefly explained by Dr. Fujita, which is called Vision Zero Summit Japan. This event is held online and 16 different sessions are planned. And session I, out of 16 sessions, the International Standardization for Safety, Health, and Well-being, which I am assigned as a session chair. I asked the key persons from IEC and ISO for presentation in my session, and they are pleased to accept the presentation in both standards development side sectors and CA sectors. Especially, I would like to take this opportunity to express my heartfelt thanks to 3 IEC Vice President, Mr. Ralph Sporer of SMB Chair, Mr. Sean Paulsen of CAB Chair, and Dr. Kazuhiko Tsutsumi of MSB Combiners. As you can see, the speakers list, the 6 speakers, including myself, were the editing member of last year's white paper, Safety in the Future. If you have any interest, I would like to ask you to join this event. And I hope that the white paper, Safety in the Future, can more or less contribute to our universal target goals of human safety, health, and well-being. Thank you very much for your attention. Thank you.
Thank you, Dr. Kajiya, very much for your presentation. And also, it's nice to see that many of the project team members are continuing on and promoting safety in the future throughout the world in different conferences. Thank you. As tradition, though, I'd like to open up the chat box for questions if anyone has anything they would like to ask. Yes, I have one question here. It says, do the standards cover guidance to minimize programming and artificial intelligence errors? Also, did Japan's safety authorities start to impose legal responsibilities on robot manufacturers or the programmer designers? So starting with the first question, do the standards cover guidance to minimize programming and AI errors?
Yes, thank you for the very interesting question. This is exactly the common question among our members. You know, especially the artificial intelligences, there is more and more used the sophisticated safety systems. But the point is that what is a limitation to control such the safety, such as the very critical, and we have been discussing now with the relevant safety authorities now, and at this point of time, I cannot say clearly the AI's the integrations, especially for the safety controlling, the active safety controlling systems. And the second question is also the same. The safety authorities. I'm a member of this project committees. How the AI and IoTs using the electronic products be maintained safe as before, and the situation is the same with the robot manufacturers and the programmers, and of course this project meeting have the variety of the different industry sectors, including the programmers and of course robot manufacturers, also the insurance companies representatives. Did my the reply answer to your questions? Or?
I do not see any other questions in the chat box, and I think you answered. Was it one more question I see here? Would it be meaningful to imagine IEC coming up with a standard that machines with AI understand, or a safety language, quote unquote, that machines can obey?
This is also the same interesting questions, and this is the common interest in our expert group. And at this moment, I cannot say a definite answer on this point.
Thank you very much. I don't see any other questions, and we are on schedule to go to our next presenter. So thank you, Dr. Kajiya. I appreciate your support to the project and also this excellent presentation today. Next, I would like to introduce Mrs. Gillian Hamilton, the CEO of Managed Damage. And Gillian will speak about future fast forward, safety now. So Gillian, the floor is yours.
You're still muted.
Gillian, can you, let's see.
I am now. Thank you.
There we go. Thank you.
Thank you. Look, thank you so much for having me along, and congratulations to my fellow team members who contributed so many wonderful parts to this Safety in the Future paper. It's ironic as we all now join each other so closely but so far away, as we sat in Geneva and we left, as we left our particular meeting, the doors closed behind all of us for COVID-19. So actually our paper got a little fast forward. So thank you to each of you who are here, and we will start off. So we've made it to the future, and I think the future is actually yesterday. In fact, if you quote a particular movie, Back to the Future, that was in October 21, 2015. So we've been in the future for quite a while, and for me and for a lot of you in robotics and AI and the work that you do in IEC, the future that we speak of is already here for most of us. We're already working in a lot of these spaces, and it's really the only advanced AI and predictives that are in test mode, but the tests have been exponential. And as the world sat by and paused during COVID and the pandemic, the technologically advanced people, they pressed the fast forward button. We hit the fast forward button. So interestingly, for those that were with me at the IEC meeting we had, I presented this slide, the megatrends in technologies for 2017 to 2050. Now, this is the work of Richard Watson from Now and Then, which was completed in 2017. And a lot of the things that he talked about during COVID have had the fast forward button pressed and has had amplification as people stood sideways, the electronics and the electrode technology and our connection moved forward. The speed of change has only incremented in vast speeds of light and of technology, and the state of change was and is constant. So for us, we are spending a little bit of time together talking about the future, but the future is right now. We have some work to do to install the future controls that we talked about in a forward tense in our safety in the future paper. But it's now a past tense for most of the work that we do because it's now. Interestingly, COVID really brought safety to the fore. Safety became the new big. And for a culture to have its best strength, we have to engage with the work of all the players in the marketplace, investors, shareholders, organizations, workers, customers, engineers, designers. Together, we all have a part to play. And we all have the affects and effects from safe products, services, activities, and processes that we design. So during the pandemic, people started to demand safety trust. No longer are we at the self-actualization phase. We are core basic down to food, water, shelter, and safety. People needed to be assured that they would indeed be safe if they brought your products or used the services that we designed. And our workers started to deeply care about their own health and safety and the health of their loved ones all at the same time. Safety became key critical with significant resulting financial impacts on organizations. And if you didn't manage the risk of COVID, you could simply not operate. The best performers, however, have been organizations and nations who provided safety trust to their customers and in all the products and services that they delivered to our people. Delivery of products in this manner is absolutely changing. No longer can we plan, design, and release a product like this. The safety globally is on the rise, and e-safety globally is instantly here, and the actions in techs and clouds now matter. Financial impacts of social systems and interruptional costs are costing billions of dollars. For example, Facebook's interruption 2 days ago, which cost Zuckerberg $7 billion in an outage overnight. The issue that we face here and the fact that we talk to IEC engineers is it's you. It's the people that are sitting in front of us today who actually have the power to be able to design, test, release, and develop products that are safe. It is in your hands. The kind of products that we have been designing in the past and letting go into the marketplace and having our customers test for us, this kind of design is not going to float in the future, especially if it's not safe. we're seeing product safety, regulators and the people of the public and investors deeply interested in what we are delivering. No longer is it remotely acceptable for a factory robot to do things like this. And even just last month, in August actually, the United Nations in Geneva had their first official diplomatic meeting on lethal autonomous weapon systems or killer robots. In nearly a year, they meet again, and we're talking about robot treaties. So again, we go to the design and the safety and the decision-making that these robots can make in their acts of service designed by us. Here we are, we have to work in harmony because the robots are here, we are here, and we are the designers of the robots. So if we work together, the best outcomes from robotics can be improved safety, can be improved health, can be reduced injuries and incidents. And it's the minds that we have sitting right with us now, from your living rooms, from your offices, from your telephones at the airport. You are the people who have the power to make this change. And we need to work out those details. And of course, it's for us before the laws come into play. So of course you spoke about the laws if they've changed in Japan. In Australia, in 2018, I wrote a book called Risk Dollarization, and we identified the challenges in the AI and robotics elements of law because they were not nominated throughout our legislation. Today doesn't need the law to change. It requires us to make those safe design decisions to ensure that change. Cyber attacks are normal now, every day. Daily, people's identities, money, and aspects are stolen on a day-to-day basis. Just this year, we had a first death reported following a ransomware attack in a German hospital in September 10. So when we've never been more connected, we're also never been at more risk, which means that it's up to us to ensure that when we place our designs and systems, that we are thinking about it. It's now time. It's time all over the world, in every clock, in every place that we have, to start helping to move in the right direction. We at IEC have always stood for making the world a safer place. We just need to design the new and the next wave most carefully, as it has more impacts, as the technical steps between humans and robotics and AI and automation are much more complex than they ever have before. The lion with the bow, if designed well, is the best tool we have. But if we don't design the bow and the lion in the best sense forward, we have got a challenge. So again, I remind you, it doesn't take the law and the standards to change. It's on us and our design. Finally, because of COVID, all around the world, being a good corporate citizen in the sense of making sure that you provide a safe place to work, safe place to visit, safe products or services, started to deeply matter to organizations and nations all over the world. And it started to fit into everybody's strategy to make their operations survive and even thrive in the pandemic environment. When the financial experts around the globe start to say that safety is part of the social license to operate, our stocks go up because we're assured eventually of a society where people are not harmed from our work. And it seems like a huge step closer. The thing is, for all of us, that we have to understand is that safety has become material, super interesting to shareholders and to stakeholders. And interestingly, the people who fund us, the people who pay for our designs, the people who want us to make things for them, they have been never more interested in measure, marking, and monitoring our work and our designs in fact, that they are safe. And when they release products, that they're going to have a great outcome from the service they're providing. The reputation aspects of poor product safety have never been more important, as customers are now deeply caring about safety. In Canada alone, the interest in safety has increased to 82% of regular citizens caring for themselves as a result of our pandemic. The investors now want to back safe businesses, safe organizations, safe designs. When they look at an organization to invest in, they want to see E, S, and G. Now, the S for society, we've got to keep society safe. The G, to ensure the governance of the products we're designing are not going to end up on the front page of the newspaper, are not going to be a mass recall because they're catching fire on every application. We need to make sure that the products that we design now are going to be shaking our tail feather for the investors to back us so we can do more great, phenomenal work. When the definition of material alters, our measuring sticks of success have to change. In the past, our investors wanted to back fast and cheap. They don't want fast and cheap anymore because they know that it's normally a unicorn and that they're often riddled with mistakes. So now our investors are looking for sustainable products, ones that are safe for society and for the end users and for the people that have to maintain them. We are actually waiting and need you, the engineers and the designers and the dreamers, to dream ethically in a way that sees all the steps from start to finish. Imagine if you, as a design engineer, could help make this change for society. You could help lead the next steps for us around the world. This paper lays the groundwork. You've already had the platform for years because you are standing on the platform of we want to make the world a safer and more conforming to design place. But now it's up to us to take that design to the next level. And we know that you have the world in your hands. So thank you, because I know that you're all ready to take these next steps.
Thank you very much, Jillian. Thank you. And we can hear the passion of your presentation and our need to become safer through standards. So I would like again to open up the floor to the chat box and see if anyone has any questions. It may take a second to come in, so just bear with me. It's easier with a microphone and standing in a conference corner, but here we go. Okay. There's a question to any speaker, but addressing safety is a very critical, as demonstrated in the white paper, and will introduce many innovative technologies to achieve the safety objectives. Are there any specific requirements on cybersecurity related to safety, I'm sorry?
I'm happy to respond in the sense that the cybersecurity obviously is one of the elements for a lot of our plant and technology in our workplaces these days. So when we're designing and when we're installing and when we have a connection between our piece of plant and the internet, it is really up to each company to ensure that the attacks and the software and the flyware to stop the entry points are as firm as possible. So when we're designing the robotics, whatever system we have, it is important to be able to have as much protection as possible. There is some laws and standards that are around that. However, the detail of that I don't have in specifics for today for each nation of the world.
Thank you. And last question due to time. And again, this is for any speaker, but Jillian, since you have the floor, says, going by the 20-year measurement of changes in safety, at what point will collaborative safety no longer be sufficient, viable, or relevant, if at all?
It's interesting actually, because I think we will morgue into a place where it doesn't feel like collaborative safety anymore, because our technology of the future will become part of our DNA and our processes as people start to have chips, not only wearable technology, but insertable technology. That evolution from human who works with a piece of plant to human, you know, with the fence on it, to human who works alongside a robot who becomes our friend, to a piece of advanced technology that we have internally within ourselves to advance ourselves, to do better, to think faster, to have access to more information. Those elements are imminent and being worked on right now. I think also Dr. Dietmar might have something to add there from his attention, I see.
Dr. Reinert?
Sorry, can you please repeat, then I will answer. What is the question?
Oh, yes, it was going by the 20-year measurement of changes in safety. At what point will collaborative safety no longer be sufficient, viable, or relevant?
I think the collaborative safety is the right way forward if the basis, and for me, digitalization, the basis for digitalization is, when we use it for safety, that we need functional safety as a basis. With this basis, we can do everything with these new systems. And when you look, for example, for the AI, we need a similar approach than we had for software in the 90s, now also for AI.
Thank you very much. Thank you again, Gillian, for your presentation. And due to the time, we now need to move to our next presentation from Mr. Philippe Joel, who is the chair of ACOS, as well as the standardization manager at Schneider Electric. Philippe, please, the floor is yours. Thank you, Gillian. Philippe, please. You're muted. Let's see. There we go.
Okay, so thank you very much for allowing me to present the next presentation. So I'm going to share first screen. Can you see my screen?
Yes, but it's not in present. Oh, there we go, in presentation mode.
Okay, so thank you very much.
Thank you.
I will try to get rid of that.
It's fine. We can see it perfectly.
It's fine. Okay, good. Thank you very much. So, good morning, everybody. Good afternoon. So my presentation is related to what we are starting to do following this publication, and even we started in IC to consider that a little bit before. In 2017 exactly, we had a first workshop on that topic in Tokyo, and since then we are in progress on developing guidance related to collaborative safety. So just an introduction, if I can. An introduction of what is ACOS. ACOS is the Advisory Committee of Safety, depending on the SMB, and we are. Our task is to guide and coordinate the work related to safety matter. So whatever the matters in IC, and we are putting together TCs, the technical committees, subcommittees, to deal with particular subjects. And the ultimate goal of that is to avoid duplications and to agree on common requirements to be referred to. So for that, we are developing horizontal standards in IC. We call that basic safety publication and group safety publication, BSP and GSP. And those are used as a reference for the product committee dealing with product standards. And you can have a link, you have the link to the ECOS website. And we have two major guides. We have several guides, of course, related to safety, but two are really important. One is really operational, which is the risk assessment guide, the AC guide 116. And you can see how we are analyzing all the hazardous situation, all the measures to compensate the risk, and to help technical committees and product standards to be developed properly. And we have another very important guide, which is the guide 104, and which is the process the technical committee has to follow to develop their publication and to refer to horizontal standards. So this is summary. So ECOS is a small group. We have 16 experts and representatives from TCs, and we are inviting guests from other organizations, depending on the interests and the topics. And we have consumer organizations represented, for example. So coming back to collaborative safety, let's say just to remind what are the major trends in IC, which are discussed today and which are the subject of some projects starting. So intelligent systems are providing really good opportunities to have, let's say, better tools to deal with safety, of course, with the digital transformation. So we are trying to dig in that technologies to get some benefit from that. Of course, this digital transformation is interesting, but at the same time, there is some drawback and possibilities of new concerns. So yes, we have to deal with new aspects which are not really detailed today in major standards in IEC, but this is coming. We have already some projects starting on that. So privacy is something which is coming and which is maybe not directly connected to safety, but as soon as you have private data associated with safety, then it's a concern. The data integrity is also maybe a problem, because if we consider safety data, then we have to make sure that those data remain in integrity. And the transparency and the trustworthiness is also important, and we are discussing that with some committees related to artificial intelligence, for example. So yes, we can benefit from ICT developments to get more in real time the information, to assess more, let's say, accurately some risk, and to let's say collect all the interaction that we can see between human and machines thanks to those technologies. So, of course, there are multiple growing possibilities of technologies coming, and which are developed in ISO and IEC, Internet of Things, ontology. So ontology is a particular topic which is also considered for safety aspects, because it can help to better exchange information between different sectors or different, let's say, activities in the enterprise to help to better cover the more complex situation related to safety. So there are multiple opportunities which are coming, and in ECOS we are considering all those as opportunities to better manage the elements of safety. So recently, ECOS received some task, and following a decision of the Standardization Management Board, SMB, and this is summarized here in 4 bullets to assess the evolution of technical developments. So this is just before what has been summarized with all the different technologies, perform a gap analysis of any missing work in IC, recommend to SMB future standardization work and roadmap. So this is, and of course, for that, we are taking the benefits of the experience of ISO in many sectors, because IC is more focused on the electrotechnology and solutions for used by ISO also, by the way. So we did a survey recently with all our contacts we have within IC, within the technical committee, system committee, dealing with let's say dealing with safety related aspects, not always focusing on safety, but having safety in their list of requirements. And we identify 3 projects which are ongoing, already started. One is a cooperation between Functional Safety Subcommittee, 65A, and the Artificial Intelligence Committee, C42. So it's a challenging topic. They would like to develop a guide dealing with functional safety and artificial intelligence. And this is very promising, and we are trying to contribute from ECOS and to help the committees to contribute to that project. Another project which is very interesting also, it's developed by 61J. 61 is dealing with household appliances and the safety of household appliances. And this project is related to autonomous floor treatment. And this is the very first example of concrete projects of products, which is already existing on the field. And 61J is developing quite an accurate set of requirements, dealing with all what is related to the collaboration between this autonomous machine and the environment, where you can find human, of course. So there are new considerations there, which are interesting. And this is providing some good triggering of discussion in ECOS and also with 65A and SC42 about artificial intelligence algorithm and the requirements we should elaborate in common. And then there is another topic which is related to smart manufacturing, a technical report, especially developing use cases. And one of the use cases is related to collaborative safety. And it is at the starting point, but I will show you the basis of this use case later. So there is also a number of technical committees really interested by the topic, and they are looking at developing new projects which are related to similar aspects of collaborative safety. So you can see exclusive atmosphere, machinery, safety of machinery, household appliances, portable tools, medical equipment, and also in functional safety, there are also some new topics which are prepared for the next edition of 61508. And also the assistant living system committee, which is also looking at some new projects. There are also some committees requesting guidance. So ECOS is already preparing a project for developing a guide about collaborative safety based on those requests from the different TCs here. And we are inviting those TCs to collaborate and to participate to the development of that new guide. This is the example of smart manufacturing, which is at the starting point, but with already a good development. So this use case is focusing on the on the self-optimization of production resources. So it's a manufacturing use case where machines are adapting themselves to the requested production product, the product to be produced. And in this context, you can have multiple possible reconfiguration of the machines and the lines, and everything should be analyzed before, of course. So there is a necessity to to collect all the dependencies of the different configurations, and to create some kind of assurance cases. So this is a new idea, to create assurance cases based on the potential new reconfiguration of the production lines. So it has to be developed, and because of the amount of data, you can imagine behind that, using digital template or digital format will help a lot to use computer assistance to express those assurance cases and to look at the critical safety aspects. And to do that and to exchange all the information between the different, let's say, involved actors, the suppliers of the different parts or goods, the manufacturing elements, the production resources. So you see that there are multiple sectors and they need to exchange information. And for that, it is important to make sure that the information which is exchanged related to risk, to the safety, will be correctly understood and perfectly interpreted. So we need to develop some semantics and data model to simplify the exchange of information across the domains. So of course there are much more detailed documents which are available in this working group 23. But it is not yet mature enough, but it will be circulated, I think, probably at the beginning of next year. So today we have collected several contributions, and the task force, which is in progress, is continuing to develop the identification of the gaps, and also to prepare recommendations to SNB. And most probably the recommendation will be given next year at the next SNB meeting, beginning of next year. And we have really specific focus, which are on the functional safety aspect related to autonomous functions. So TC65 is clearly involved there. And also the trustworthiness, which is a concept well developed by SC42. And we are also using the support prepared by Japan about many use cases which has been developed in Japan, which are in the scope of ISO, but we are trying to identify what should be the contribution of IEC in those ISO use cases, let's say. And we are still, let's say, working on the definition of the collaborative safety in terms of technical definition, and this is not yet mature enough today, unfortunately, but we are spending a lot of effort to clarify that and to make that understandable by the technical committee, and this is our task in IC ECOS. Yeah. So next step will be the report in February. Huh? And that's it for my presentation. Do you have some questions?
Yes, thank you very much, Philippe. Thank you for giving us the progress on the task force and also for showing us promising new works in ACOS. I do have one question, which I think you answered a little bit already, but I'll let you answer it from here. It says, does collaborative safety always imply the presence of a human element? I know you said you have not defined.
Yes, it is in the principle. You have been already looking at the different presentation. Collaborative safety means exchange of information related to safety between three entities: the machine, of course, human, and the environment. Environment means the management infrastructure. So yes, human is always the topic, which is the, yes, this is a topic related to safety. Otherwise, we cannot say this is safety.
Very good. I have time for one more question. Okay. I don't see any. So next, I would like to turn it back over to the Market Strategy Board convener, Dr. Tasumi, please, if you have some closing remarks for the seminar.
Okay, thank you, Peter. And a big thank you to all of speakers and you, our audience. I hope that this conference has given you some valuable takeaways. As I mentioned in my welcome remarks, the slogan of the MSB is bringing the world to the IEC. In the coming years, the MSB will continue its work to bring knowledge from outside the IEC into the IEC. I sincerely hope that we will be able to meet in person next year and once again be able to hold this conference. Thank you very much.
Thank you, Dr. Tasumi. And from me as well, I would like to thank all of our speakers today. It was a pleasure working with you on the project. I'd also like to thank all the participants. We had over 200 registrations, and I think we peaked out around close to 200 during the middle of the seminar. But again, I hope you find this well worthwhile, and I intend to share the presentations on a platform to be decided upon later. So thank you all. Thank you to my colleagues, and thank you to all participating here in this conference. Thank you. Goodbye.